Welcome to IB.
Alright, hello. So for today, we are going to talk about the sequences, which is under the lesson 2.1 in general mathematics and under strengthened senior high school new curriculum. But before anything else, let's talk about what is a pattern. So a pattern is a repeated or predictable arrangement of numbers, shapes, colors, or objects that follow a certain rule or order again. Pattern, repeated, predictable, follow a certain rule or an order. So pattern can be found in the nature. It can be seen in animals such as zebra, giraffe, fishes, and so on and so forth. And of course, we can see patterns in plants, flowers, and so on and so forth. So, patterns can be found in nature. Also, we can find the patterns in arts. So, pattern can be found also in arts. Now, let's have the sequence. So when we say sequence, it is a special kind of pattern wherein it is an ordered list of numbers or terms arranged according to a certain rule. So in every item in a sequence, it is called a term. So we have here an example: 1, 2, 4, 8. What do you think is the pattern in this sequence? Multiply by 2. Okay, let's try. 1 times 2 equals to 2. 2 times 2 is equal to 4. 2, 4 times 2 is equal to 8. So we can say that the pattern in this sequence is multiply by 2. So when we multiply 8 by 2, it is equal to 16. We need to continue the process. 16 times 2 will be 32. That's how sequence works. Now let's move on. What about on this example? For the second one, we have here 1, 1, 2, 3, 4, 5. So what do you think will be the pattern in this sequence? So as you can see, we can say 1. Here, it becomes 0 plus 1. And then 1 suddenly become 2. So it could be 1 plus 1. And then suddenly, here, it becomes 3. So it could be 1 plus 2. And on the other hand, to get 5, we have 2 plus 3. So as you notice, in each term, it is equal to the sum of the two preceding terms. Each term is the sum of the two preceding terms. So let's continue the process. So here we are done with 2 plus 3. Then we are done with 1 plus 1, which is 2. 1 plus 2, which is 3. 2 plus 3, which is 5. Now, what is the next step? We have 3 plus 5, which is 8. And the last one will be 5 plus 8, which is 13. There you go. Last example. So in this example, we need to examine the pattern. So here the 4 becomes 8. So what could be the pattern? So let's say add by 4 plus 4 is 4 plus 4 is 8. When we add 4 to 8, we have 12, which is correct. So the next pattern will be 12 plus 4, 16. And the last one is 20. So here the pattern is add 4. So we need to, the pattern in this sequence is add 4. Alright, now let's move on. And the key terms and definitions that we need to ponder. So the first term is a sequence. So when we say sequence, it is a list of numbers arranged in a specific order following a rule, just like what we did a while back. Again, sequence, a list of numbers arranged in a specific order or following a rule. So for example, we have 3, 6, 9, 12. That is our example. So here the pattern is multiplied by 3. Another example, we have 4, 12, 36. So here the pattern again is multiplied by 3. Alright, the next term will be the term. So when we say term, each number in a sequence. So for instance, we have here 3, 6, 9, 12. So here, those are the terms. Those are the terms. Again, the number in a sequence, it is called term. These are term. Next one will be the position, or we are done with term and sequence. For the third one is position or the index. It is the place of a term in the sequence usually counted as first term, second term, and so on. So in this example, this will be our first term, second term, and so on and so forth. Third term, fourth term. So that's how we do it. Next one is for the notation. For notation, we have A1 will be the first term, A2 is the second term, etc. In general, A of n denotes the nth term. Again, this will be first term, second term. And for this one, the nth term. Next, for the fourth definition will be the rule or the pattern rule. So it is a description of how the terms is formed or how they change from one to the next. So let's say we have an example of 3, 6, 9, 12 here. So in this example, we can say that the pattern is multiply by 3. Another example, let's say we have a sequence of 2, 4, 6, 8, and so on. So here the pattern is add 2y. In the first term, we can get the second term by adding 2. In the third term, we can get it by adding 2 to the second term. For the fourth term, we can get 8 if we add the third term into 2. There you go. For the last one, we have a Fibonacci sequence. So when we say Fibonacci sequence, it is a sequence where each term can be get after the first two is the sum of the preceding terms. So here, we have done this a while back. For example, we have 1, 1, 2, 3, 5, 8, 13. That is the example. So here, we tend to add the two preceding terms, we will get 2. 1 plus 1 is equal to 2. Now let's move on. 1 plus 2 is equal to 3. Alright. I'm going to repeat it. Again, for the Fibonacci sequence, the example here is 1, 1, 2, 3, 5, 8, 13. So here we need to add the two preceding terms in order to get each term. So here we have 1 already. So for us to get the third term, we need to add 1 plus 1 and 1. So here we will get 2. If we are going to add this is 1 plus 1 and we get 2. If 1 plus 2, we will get 3. 2 plus 3, we will get 5. 3 plus 5, we will get 8. And 5 plus 8, we will get 13. So we need to add the two preceding terms in order to get each term. Now let's move on. What about the classification of sequence? So this is based on the number of terms. So we have 2. First one is the finite sequence. So when we say finite sequence, it has a specific number of terms. It has a beginning and an end. For example, for the finite sequence, we have 2, 4, 6, 8, 10. So this sequence has 5 terms and it ends with 10, ends at 10. So it has 5 terms, 1, 2, 3, 4, and 5, and it ends at a specific point, which is 10. So for the finite sequence, we can count all the terms. Again, you can count all the terms. And it stops after a certain point. So again, in this example, we have 2, 4, 6, 8, 10, and it has 5 terms. The first term is 2, the second term is 4, and so on. And it ends at 10. That is the finite sequence. So we can count all the terms, but it stops after a certain point. In this example, we have 10, which is the 5th term. First term, second term, third term, fourth term, and 5th term, which is 10, and we end at 10. Next one is infinite sequence. When we say infinite sequence, it has no end. It goes on forever from the word itself, infinite or infinity. It keeps following the same rule endlessly. So for example, we have 1, 2, 4, 8, 16, 32, and do not forget to put the ellipses. Again, this is what we call ellipses. So in this example, the pattern is multiplied by 2. 1 times 2 times 2 times 2 times 2 times 2, and it goes on forever. That is infinite. While for the finite, it has an end. For the infinite, it has no end. It goes on forever. So in this case, you can describe the rule, but you cannot list all the terms. All the terms. Again, when we say finite, it has an end. For infinite, it has no end. So let's have an activity.